As we have done previously, we can show the relationships of properties graphically. Fields are no different. Here, though, we look at the variation of properties as we move from the centre of the field to its outskirts. To do this, we draw a graph with displacement from the centre of our field along the x-axis and our other properties along the y-axis. We are only interested in field strength and potential at the moment, so these will go along the y-axis. The field is at its strongest at the centre of our field. We know that because r is very small at this distance, so any number divided by this small number will be very large. As the distance from the centre of the field increases, the field strength decreases until there is no field strength at an infinite distance, as there is no field. The potential is the reverse of this. At infinite distance from the centre of the field, the potential is zero. As we move closer to the centre of the field, the potential decreases, whereas field strength increases, until it is at its maximum negative value at the centre of the field. If you were to move the centre of the field, then the field strength and the potential would be infinite. But potential would be a negative infinite, and the field strength would be a positive infinite. In reality, there is a mass with proportions at the centre of the field which prevents the field strength and potential from becoming infinite. Our probe mass and field mass never overlap. If there was no mass at the centre of a gravitational field, then field strength and potential could go to infinity, which is one of the problems with black holes. For completeness, it should be noted that potential and field strength are linked graphically. Field strength is the negative of the change in potential divided by distance from the centre of the field, as discussed in a previous podcast. The change in potential divided by a distance from the centre of the field is the gradient of the potential field. So gravitational field strength is the negative gradient of potential against distance from the centre of the field.